Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss bond enthalpy. This topic has been taken from the NCERT Chemistry Class 11 books. This is the unit number 4. Today's class number is 073. Bond enthalpy is defined as the amount of energy required to break 1 mole of bonds of a particular type between two atoms in a gaseous state. This is the definition of bond enthalpy. Here always you have to remember the amount of energy required. Always mention 1 mole of bonds and a particular type of compounds in which the bond between the two atoms it needs to break and how much amount of energy required, that is called the bond enthalpy. The unit of bond enthalpy is kilojoule. Kilojoule, we know the unit of energy per mole. Per mole, we write usually MOL superscript -1. Now example. In case of hydrogen molecule, we know H single bond H bond is there. So its bond enthalpy is 435.8 kilojoule per mole. And bond enthalpy is denoted by delta AH. It is written there in an equation form. You see the H2 in gaseous form, it need to break to form 2 hydrogen atoms in gaseous form. It needs the energy 435.8 kilojoule, and so its bond enthalpy delta AH is equal to 435.8 kilojoule per mole. Another example we will see when it has multiple bond, because for hydrogen molecules we have seen one single bond. Now for multiple bonds, the molecule will consider for oxygen. Oxygen has double bond. In this case, the bond enthalpy is 498 kilojoule per mole. And for the nitrogen molecule, we know nitrogen molecule has triple bond, and for nitrogen molecule to break this molecule into 2 numbers of nitrogen atoms in gaseous form, then bond enthalpy value is 946 kilojoule per mole. Or multiple bonds, that means here double bond. For double bond, you see it is the 498 kilojoule per mole. But for nitrogen it is a triple bond, then bond enthalpy increased, is the 946.0 kilojoule per mole. The larger the bond dissociation enthalpy, the stronger will be the bond in the molecule. That means the nitrogen molecule is bond, triple bond is more stronger than the oxygen molecules which have the double bond. We'll consider the heteronuclear diatomic molecules like HCl. H is one type of atom, that means hydrogen atom, and chlorine is another type of atom. That's why it is the heteronuclear diatomic molecules. And for this, the bond enthalpy is 431 kilojoule per mole. Now we'll consider about the polyatomic molecules. Example is water molecule, H2O molecules. In this case, the enthalpy is needed to break each of the two OH bond is not the same. Here in this figure, right side figure, you see that water molecule has two numbers of OH bond. This is one bond and this is another bond. But the energy required to break each bond are not the same. So first, when H2O in gaseous form, it dissociates, or it's suppose this bond we need to break in hydrogen atom in gaseous form and OH in gaseous form, then the bond enthalpy is 502 kilojoule per mole. Superscript 1 means to break one hydrogen atom, first hydrogen atoms. And again, when from the OH in gaseous form, we need to break into hydrogen atom in gaseous form and oxygen atom in gaseous form. In that case, the bond enthalpy is reduced and it is 427 kilojoule per mole. So for the polyatomic molecules like water molecules, the bond enthalpy is different for different bonds. The difference in this bond enthalpy value shows that the second OH bond, that means O single bond H bond, undergoes some change because of changed chemical environment. And that is also reason why the bond enthalpy is different for the OH bond for ethanol, that means C2H5OH, and water, that means H2O. Though they have the same O single bond H bond, but due to the chemical environment, different types chemical environment, this bond enthalpy for OH is different for ethanol and water molecule. For the polyatomic molecules, we generally use the term either mean or average bond enthalpy is used. So we'll use now average bond enthalpy. And for the H2O molecules, now we know that 2 OH bond, it needs to break, then it requires different energy, and we have to average of this to get the average bond enthalpy of OH bonds. And after averaging, we get the value 464.5 kilojoule per mole. I hope that you understand bond enthalpy. What is the point for changing the bond enthalpy in respect of single bonds, multiple bonds, same bonds, but different molecules, and also average bond enthalpy. You understand how to calculate it. I have podcast in the name of Dr. Acharya Academy for high-level chemistry educations. You can go through this to get more knowledge. Thank you so much for watching this class.